Welcome CIS 255. In this video we're going to talk about C++ pointers. Let's start with this example. I already have an empty project which I created today, and I'm going to view its Solution Explorer, and you can see that there are no source files. So I'm just going to add a new item which will be a C++ file. Name it main.cpp, and I add source subfolder to keep my source files in a specific directory. I can now close my Solution Explorer and simply copy this example over to my source. Okay, so here we're creating two local variables, an integer and a double. C++ has size of operator. You can see it's highlighted, so it's a keyword which can take the name of the object or a data type and return its size. The size of an object is returned in bytes. So for example, if my integer is 32 bits in memory, it means that size of will return a positive value of 4, which is the size of an integer in memory in bytes, 4 bytes. Likewise, a double is going to occupy on my computer 8 bytes. And so these are the values that size of returns. But what about the variable addresses? There is no address of keyword in C++. Instead, there is an ampersand operator which will return the address of the variable in computer memory. In fact, I can actually get rid of these parentheses so that we're just applying a unary operator ampersand, the address of, to an object which has allocation in memory, and we can say that the ampersand means address of. So it's going to tell us what is the address of an X and what is the address of D in computer memory. So I'm just assuming here that as we discuss, once we create a variable, it is getting allocated somewhere, and I will use a box to represent this integer 5 and another box that is roughly twice the size of the first one, and this will store a double value 0.1. So the size of measures the size of objects in bytes. Both of these variables have specific memory addresses. These memory addresses are likely to be some sort of random memory locations, and the address of operator will simply provide us the actual number specifying the address. Another important thing to consider is what is the type of the value returned by the address of operator. So the size of operator return a plain value that we were able to accommodate as an integer value. However, when we're obtaining an address of a variable, we have to modify the actual type of this variable, which is supposed to accommodate the address of another object. And we need to apply a type modifier that looks like an asterisk, and this type modifier is called address of or pointer. So to rewind this entire declaration of a variable X address and D address, what we can do is that we can say that X address is a pointer, or X address is an address of an integer. So once again, this variable is an address of, or this variable is a pointer to an integer. So when we create an integer like this with the value 5 in it, x address here is also a variable which we can conveniently diagram as a pointer to the location of this variable x in computer memory. In this example, we create 6 variables: an integer, a double, 2 more integers right here, and 2 pointers. So like I said, it's easy to envision that pointer is a variable that contains an address of another object, and somewhere in a diagram of this memory we can show that pointers actually know the location of the variables to which they're pointing to.